Hey everyone, and welcome. If you're getting ready for your chemistry exams, WAEC, JAMB, or NECO, then you are in exactly the right spot. Today, we're going to make the properties of solids and liquids super clear so you can walk into that exam hall and handle any question they throw at you. Let's get right into it. So let's start with a really simple question. You can pour a glass of water, but you can't pour a block of ice. I mean, it sounds super obvious, right? But have you ever stopped to think about why that is? The answer to this simple question is actually the key to understanding this entire topic. You see, the whole difference between that solid ice and that liquid water comes down to just one thing: how their tiny, invisible particles are behaving. Everything we see and experience on our scale is really just the result of what's happening on a microscopic level you can't even see. And the big idea that explains all of this is something called the kinetic theory of matter. Seriously, if you can get your head around this one core concept, everything else we talk about today is going to fall right into place. So what is it? Well, the kinetic theory basically says that everything around us, solids, liquids, gases, you name it, is made of tiny little particles. And these particles are always moving. They are never completely still. The big difference between the states of matter is just how much they are moving. And that all depends on how much energy they have. More energy means more movement. Simple as that. Let's start with solids. I want you to picture a perfectly organized crowd of people, packed in super tight, shoulder to shoulder. They can't really walk around, right? But they can kind of shuffle and vibrate in their spots. Well, that's exactly what particles in a solid do. They are locked into this fixed, orderly pattern, just vibrating with a low amount of energy. Okay, now let's look at liquids. The particles here have got a bit more energy, so they're still pretty close to each other, but they aren't locked in place anymore. This time, imagine a busy marketplace. People are still crowded together, but now they can move around, sliding and weaving past each other. That ability to slide around is what makes a liquid a liquid. So we've got these tiny particles either vibrating in solids or sliding around in liquids. But how does that microscopic action lead to the properties we can actually see and measure? Why is a rock hard and why does water flow? Let's connect the dots. This table really lays it all out. Look at how everything connects back. A solid has a fixed shape because its particles are locked in place. A liquid can take the shape of its container because its particles can slide around. And look at compressibility. Since the particles in both are already packed so close together, you can't really squeeze them any tighter. Every single property here goes right back to the kinetic theory. All right, knowing the theory is one thing, but the real goal here is to use it to answer exam questions, right? So let's jump in and tackle some real past questions from WAEC, JAMB, and NECO to see how this stuff actually shows up. Okay, here's our first one. This is a classic WAEC-style question. It gives you a fact from the kinetic theory and then asks you what that fact explains. Read it over carefully. Based on what we've just talked about, which one do you think is the right answer? Let's walk through it. The question is specifically about particles moving faster in a gas than in a liquid. So what does faster movement allow particles to do? Well, it allows them to spread out and mix much, much quicker. And the scientific term for that is diffusion. So this directly leads us to option C. Gases diffuse faster than liquids. Now, a very common mistake here is to pick option B, and it's tricky because B is a true statement. Liquids do flow while solids don't. But, and this is key, the question asks you to compare gases to liquids. Option B compares liquids to solids. You have to make sure your answer directly follows from the premise given in the question. All right, let's switch gears to a JAMB question. You'll notice this one is a bit different. It's less about pure theory and more about being a detective. They give you a whole list of clues and you have to figure out what kind of substance it is. Take a second and read through all those properties. So how do we solve this? We hunt for keywords. First, it says crystalline solid. Boom, we know its state. Then it mentions sweet taste and a C to H to O ratio of 1 to 2 to 1. Those are classic giveaways for a carbohydrate, something like glucose. You put all those clues together, and the only one that fits is C, a solid carbohydrate. You know, the easiest mistake to make on a question like this is just to get overwhelmed by all the details. But that word crystalline is your single biggest clue. By definition, crystals have that orderly packed structure of a solid. And here's a pro tip. For exams, it really helps to just memorize the states of common compounds, like knowing glucose is a solid at room temperature. And for our last practice run, here's a NECO question. This one is a very direct test of your basic knowledge. It's just asking which one of these statements about solids is actually correct. Let's just run through the options real quick. A says solids are less orderly than liquids. Nope, it's the other way around. B says solids have lower densities. Usually, not true. C says solids have greater kinetic energy. Definitely not true. That leaves D. Solid particles cannot be easily compressed, and that is absolutely right, because their particles are already packed in so tightly. D is our answer. I've seen a lot of students get mixed up and choose A, but you have to remember that crystalline structure of solids is the very definition of being orderly. So here's a good general tip for multiple choice questions. Always be careful with statements that use words like less or not, and when in doubt, go back to your core definitions. They are your anchor. Awesome work. We've gone through the theory, we've seen how it's applied in real exams, so let's do a super quick recap of the most important points just to make sure they're locked in. So to recap the absolute must-knows, the kinetic theory is the master key that explains everything. From there, you just need to remember that solids have fixed particles that just vibrate, while liquids have particles that are still close but can slide around. If you understand that, you can figure out everything else. And for your exams, remember, for JAMB, they really like to test those big picture conceptual differences. For WAEC and NECO, you've got to be precise, especially with calculations. And here is a golden tip for any exam. If you get a theory question, draw a simple particle diagram. It's such a fast way to prove to the examiner that you know what you're talking about. Okay, now is your turn to put this all into practice. I've got a few challenge questions for you here, designed in the style of each of the major exams to really test your understanding. Go ahead and pause here and really give this a shot. For the first two, think about the forces between the molecules. And for that JAMB question, think about what property is absolutely essential if you want to transmit pressure. This is how you really build that deep understanding. So we've nailed down solids and liquids, but what about when matter changes from one state to another? Why does a puddle of water just vanish on a hot day? Well, that's exactly what we're going to get into in our next explainer on changes of state. Thanks for tuning in and keep studying smart. To practice more questions like these, visit examkp.com. Good luck!